Hello, everyone, and welcome to the latest edition of our Lightning interview series. And as always, we want to make these sessions interesting and interactive, so please do not forget to introduce yourself. Tell us where you're joining from, what you're doing, any interests that are relevant. So today's interview, as you know, is with author, educator, and lead AI advocate at Google, Laurence Moroney. And our topic is machine learning and deep learning with TensorFlow. However, before we start, I want to say a few quick words about upcoming events at ODSC. Now, the main event, as you may know, is ODSC Europe is happening next week on June 15th and 16th at the London Tobacco Docks. I'm super excited to be back there to meet many of you in person. Our first time in Europe in 3 years. And by the way, our guest will be presenting a session on TensorFlow at that conference on the 16th, I believe. And in addition to that, as you can see on this slides, there's a number of QR codes. We do have a whole series of free webinars coming up. The first one on June 21st is on machine learning observability and model performance tracking. That's followed on June 23rd. We have a webinar on the future of conversational AI. And next we have on June 29th, a pretty apt title on MLOps, making it cool again. And next we have after that, we do have a demo talk pass for Europe as well. So that may be of interest to a lot of you. Demo talks this year, apart from the webinar, we're just talking about making MLOps cool again. MLOps is going to be a pretty, I think we've got a lot of talks in MLOps. Of course, we'll be covering machine learning, deep learning. NLP will be strongly featured. And because London is a hub of finance in Europe, we will have quite a few talks on machine learning for finance. So again, you know, if you have a chance, scan that code or do go visit our ODSC website. And we're somewhat at capacity for ODSC Europe and London. London's a pretty small venue. We do have in-person passes for our Expo Hall. But if you can't make it to London, or you're quite busy, then there is a virtual pass you can take advantage of it. So, and that's not just live stream on Zoom. We do actually have our own platform there. So we have our own networking. There's loads of extra events, and you get access to most of the agenda in that. So check it out, scan the QR code, or hit that link and check out our website and avail one of those free passes. And by the way, there is a community service we offer called AI Plus Careers. At most conferences we run, we do have what we call a career fair to help people get started on their first job or their next job when the AI community. So if you do have a job, if you're an employer, you have a job, you're looking for someone to fill that, it's a free service. You can post a job there. If you're a candidate, you can go in and look at those jobs. But it's kind of like, I kind of like call it the Netflix for job recommendations, because you go in there, we look at jobs right across the AI industry. So you'll get all kinds of jobs you can apply for directly. And it's a good way of beating what we call the ATS systems. So now you have AI working on your side. And let's see, my last slide here is on our AI Plus training platform. So lots of people ask us if these sessions are recorded. Yes, they are recorded. And then I think in a couple of days, this will be available on our AI Plus training platform. And actually, any interview we've done previously will be available on that as well. Our conference content is on there and lots of other content. So you can subscribe for that for free. And I think you will be getting an email about that once this session is over. So with that, I would like to welcome today's guest, Laurence Moroney. Laurence, welcome to the show.
Hi, Seamus, and hi, everybody. Thanks for tuning in.
So Laurence, I got to say, I'm very jealous. Not only the fact that you're dialing in from, I know your home is on the West Coast, but you're dialing in from Dublin. But apart from that, I think you've got one of the coolest jobs in AI. So on your website, which I was looking at yesterday, you say your job at Google is to educate, inspire, and inform the world about AI. But in addition to that, you are a massively prolific author. You've written fiction and nonfiction, well, mostly technical books, and you have over a dozen courses on Coursera. You have other courses out there. So I got to ask you, Lauren, do you have a life?
No, none whatsoever. No, actually, surprisingly, it's one of those things. I have a wonderful life that I really enjoy. I have a great family that I can get to spend some time with, and but I think it's just one of those things that they always say that when you love what you do, you never work a day in your life. And I think a lot of this was that I really love what I do, and I've been able to be efficient at being able to put material out there and maybe reuse some things that turn courses into books or turn books into courses and that kind of thing. So while there's a lot of output, it's not quite as much effort as it might seem.
That's fantastic. And you guys tell me your secrets one of these days, because I'm still in awe of how you've managed to do so much here.
One funny part of that is I adore the sport of baseball, and I really enjoy watching baseball. And if you know anything about the game of baseball, a game takes about 4 hours, and it's very slow paced. And it's not like other sports like soccer or rugby where you have to be tuned into it. It can be very much a background thing. And most of my writing is done during the baseball season, because instead of sitting in front of the box for 4 hours watching very slow paced game, I actually rather have it in the background, and I'm typing and working on books or working on articles or working on courses while that happens. And given that baseball has 162 games in a season, it gives me plenty of bandwidth to be able to work on these kind of things.
So let's see here. Multitasking is first, and second of all, find something you love, write about it while you're listening to something you love.
Exactly.
Nice. Actually, that is a good trick. So, it's always my favorite question of these interviews, and I think you've such a fascinating story, interesting story. So, tell us about your journey to becoming. A lot of people in the industry know you as the AI guy. So, tell us your journey about becoming the AI guy.
Oh, wow. It's actually kind of funny, because it began in like the early 90s, because I studied in the UK, and I graduated with a physics degree right in the middle of a recession. And having a physics degree and an Irish accent in London in the early 90s in the middle of a recession meant that it was very hard to get any kind of work. And the government actually started a scheme where they wanted to create a cohort of 20 people. And those 20 people, they would teach them AI so that these people could then maybe become a spearhead in industry to help AI go into British industry and maybe like help the British economy. I thought it was brilliant foresight on their part, but of course it was 1992, and I was one of the 20 that was selected. And being 1992, we entered into the famous AI winter. And the reason for that was that while the theory of machine learning and the underlying mathematics of machine learning was sound, the compute power to be able to do it and the compute power to be able to do it cost effectively just didn't exist. And the whole thing fell down, but I got bitten by the bug. And some 20 plus years later, while I was working at Google, our CEO Sundar mentioned that we want to turn Google into an AI first company. And as part of that, we were retraining all of our engineers in AI. But one of the things that I noticed was about how the training was done was very much in the fundamentals. It was about the mathematics. It was about the underlying theory. And while that's all really interesting, all really cool and all really fun, it wasn't, there wasn't much application to it. There wasn't, here's how you take this and improve industry with it. And I kind of just made that comment and made that feedback to the folks to say, we really should be teaching it in a different way. Teaching it like to be oriented towards coders and people who can apply this kind of thing instead of the fundamental theory. And then they went, okay, you do it. And here I am. So just ended, that was like about 5 years ago. So then just moved over to work on the Google Research, Google Brain team. We're now part of like what's called Google Core, and just building out the underlying infrastructure and also educating, informing, and inspiring the world about the possibilities of machine learning. And you don't need to go back to your high school calculus or your college calculus to be able to understand it.
Yeah, no, for sure. We started running ODSC conferences back in actually it's a precursor called the Boston Data Festival in 2013. But I do remember when TensorFlow came out, it's already so difficult to become an AI engineer or a data scientist. Like there's so many, you have to know the code side, you have to know the math side, you have to know the frameworks. And when TensorFlow kind of exploded on the scene, and it literally did explode on the scene, that extracted so much of that. But we'll talk about a bit about that later. But first, I want to go straight to the topic of today's conversation, and in particular, one of your many books, which is AI Machine Learning for Coders. Tell us what inspired you to write that book. And I don't know who your team is, and don't tell me it was your team doing badly in the World Series, but suppose what was the true inspiration behind that? Who is your team, by the way?
My team are the Seattle Mariners, and they actually hold the unique record for being the American sports team in any of the major sports that has the longest playoff drought. So we are the most miserable fans of any sport in the country, but we still love our team. But yeah, so yeah, watching Mariners would be where I was doing it. But I think the inspiration for this was like back to the conversation I was mentioning earlier on, and it's when I look at it from the perspective of how can you be successful quickly with AI, you can be successful quickly by writing code, and you can be successful quickly without understanding the underlying theory and the underlying concepts, because often if those are the first things that you see, you can be put off. I know I was. You know, when I first started looking at machine learning and I see like lots of equations with Greek letters and trying to figure out what a differential equation is again, that I dust off those neurons in my brain that I haven't used for many, many years. You know, it was one of those things that led to a lot of friction in learning it. But I always like to share, and in a lot of my keynotes, I share that when you look at the population of people in the world, there are some 25 to 30 million software developers in the world, and there are about 500,000 AI practitioners in the world. And all of the material is aimed at the 500,000, or was aimed at the 500,000. But wouldn't it be great if we had material that we could aim at the 25 million? And if we want to be transformative, you know, aim that material at the 25 million. The two most popular languages amongst those folks are Python and JavaScript. Python in particular is the one for data scientists, and a lot of the data science libraries are out there. TensorFlow is supported in Python. So if we say, why don't we start with showing them how to code in Python and showing them how to code simple neural networks? And there's a beautiful high-level framework called Keras, which is now a part of TensorFlow, that, you know, if we can start showing people how they can be successful building neural networks and then expanding into more complex and exotic neural networks for things like computer vision and natural language processing and the like, then when people start solving problems, even toy problems, but when they start solving problems and, you know, they see that this stuff works and they can do it, then it becomes like, hey, you know, I can do this. And you're reaching those millions of people, you know, with a skill set that they can learn. And that's when that kind of transformation that, you know, the World Economic Forum talk about artificial intelligence being the fourth industrial revolution. But the fourth industrial revolution won't happen inside of classrooms. It'll happen inside of small businesses. It'll happen inside of startups. It'll happen inside of enterprises who all start adopting this stuff. But in order for them to be able to adopt it, we want the on-ramp at least to be easy. You know, get you showings that you can, to yourself, that you can do this, get you solving problems that you can understand. And then also once you reach that type of critical mass, then people who aren't technical, when there's enough of an understanding or enough of a population of people who have an understanding of not just what it is, but also what it isn't, then you can start ideating and you can start coming up with like new solutions to problems that like nobody's ever encountered before. Let me give one example, if I might. There's one lovely project. You can find it on youtube.com/TensorFlow. And it was a bunch of high school students in India who saw a problem, and the problem was air pollution. And they had elderly parents who would often turn on the news and they would see the air quality index. But the air quality index on the news would be at a sensor at the news station, which may be many miles away, but air pollution is very highly localized. And they might see, hey, it's good to go out today, but then they go out and they suffer from breathing pollution or vice versa. So these students realized that with machine learning, you could actually build a very simple app where you walk around with an AQI, measure whatever the device is that you measure air quality index, and you take photographs of the sky and you label those photographs with the air quality at that time. And then you could build a machine learning model that matches like a picture of the sky to an actual air quality index, put that on a mobile phone, and now anybody can go out and take a photograph of the sky and get a reading of the air quality index right outside their front door. You know, that kind of thing. What expensive?
Yeah,
what I can't remember the name of the device I'm measuring. So like problems like that were the kind of things that like the average person could solve. You didn't need a PhD. You didn't need to be a Google or a Microsoft or an Amazon or a Facebook. You know, like a high school student can now have the tools to be able to build something like this. And that's really what, you know, where we feel that you'll be able to transform the world.
Yeah, it's so powerful. And by the way, we're just sharing a link to Laurence's book on the chat there. And I see many of you introduce yourselves, so keep it up. Please do introduce yourself. Let us know who you are, what your role is, and all that good stuff. Yeah, and Laurence, what I like about your book, I was reading it a couple of weeks ago, You wrote the book from a coder first perspective, which I think is great because a lot of deep learning books try and do too much. They try and like do code introductions and then the math and then the machine learning, and it's like it's a lot for people to cover. So the fact you built from a wrote it from a code first perspective, and so I can see why that's important. But I still think this book is very accessible to people who may not, who are just getting started in Python, because you have a GitHub repository as well. So just walk us through that a little bit.
Yeah, that's the GitHub repository is just lined up with each chapter of the book. I kind of wrote the book in two parts. The first half of the book is really all about common machine learning algorithms and machine learning model types that you can use to solve specific problems like computer vision, natural language processing, sequence modeling, that kind of thing. None of the, or very little of the underlying theory and math, and just very much focused on the code and what the code means. Like, so for example, like with natural language processing, one of my favorite model types is called an LSTM, long short-term memory. And instead of needing to go into all of the math about how LSTM works, I kind of give basically, from a very high level how it works, and how it's very, very good for language, and then go into the code for doing that. And again, to follow the same theme that I mentioned, that if people start writing stuff and they start getting that very basic understanding and then do something successfully, that will whet the appetite to learn more. Right? You don't need to be an aerospace engineer to know how to fly a plane, right? And you can learn how to fly a plane without knowing how all of the parts work. But if you know how all of the parts work, you will be a better pilot, right? You don't need to be a mechanic to drive your car, but if you know how an engine works, you'll be a better driver. But in this case, I really
One can hope.
Yeah, I hope so. But like that's really the aim behind the book. And then the second half is like putting it into practice. So like taking models and putting them onto mobile phones or putting them onto web servers or things like that, so that you can literally put the models that you create in people's hands, like the Air Cognizer project that I mentioned earlier on.
Yeah, and again, just for our audience, because I know this career, regardless of what step you are on it, can be pretty daunting. But I gotta say, the whole TensorFlow team organization at Google has done a fantastic job of not just providing the educational materials, but the subsequent models you can use to follow up with those. So we were talking about a little earlier, the model hub that TensorFlow has. So not only can you access content from GitHub that are related to the book, but also a lot of those models you were saying earlier, Laurence, are just ready to go out of the box, and then they can do some tuning. So maybe tell us a little bit more about that.
Sure. So one of the things that people can really take advantage of early on in your path is the ability to do what's called transfer learning, also known as standing on the shoulders of giants, because like often, there are models out there that have been trained by the likes of Google, where we have access to millions of images to be able to train a model with thousands of classes. But for you to be able to do that yourself is hard. Getting access to the data, getting access to the know-how to be able to train those models is hard. And when models are trained on large amounts of data like that, they're very good at generalizing. So a model that has been trained to recognize, there's one famous one called MobileNet that's been trained to recognize 1,000 classes of image and do it very quickly, so it's friendly on mobile. But the things that it did to be able to learn those thousands of, that 1,000 classes of image, though that the framework and the architecture of that, you can probably use 99% of that in your own model with something called transfer learning, and then be able to take advantage of that. And we call it, it sounds gruesome, but you cut off the classification head. There's 1,000 neurons on the bottom layer for those 1,000 classes, and say you want to train a model to recognize flowers, and you have a data set of like several dozen images of each of 5 classes of flowers. Then you cut off the 100 neurons at the bottom, you replace it with 5 of your own, you freeze all of the rest, so everything that model has learned, and you pass your images in, and then in just a few seconds, instead of hours or days, you can train a model to be able to recognize those flowers and do it very quickly and with high accuracy. So that's the idea behind transfer learning. So thoroughly recommend looking at TensorFlow Hub. There may be lots of models in there that are for a specific task. Like, I always like to use the example of, there's a great model in there for recognizing birds, and it recognizes a whole number of different types of birds. And you may not want to build an application that recognizes birds. You might want to build something that recognizes dogs or dolphins or whatever. But the things that model has done to be able to recognize birds, that type of generalization could be very useful for you if you were building a dolphin classifier or a bee classifier or whatever, that type of thing. So you could, really, really take advantage of that. So always recommend to go into Hub, take a look at some of the models. There's usually working code associated with them that will give you a head start, and it's always fun.
Excellent. Yeah, and just going a little, diving a little deeper here, excuse the pun. Chapter 3 of your book already covers what you just mentioned about computer vision. And in particular, you go into depth on convoluted neural networks, there, CNNs, which are quite powerful. So, just for our audience, tell us why those algorithms work so well, and are there others that you would recommend they look at?
Yeah, so sure, CNNs are amongst my favorites because they begin to work a little bit more like the way we work, right? So when you're teaching a computer to recognize an image, you're looking for patterns of pixels within that image that might match something. And that can be useful and that can be powerful. But when you're using CNNs, what you end up doing is you're filtering the image for features. So for example, if I were to ask you, what's the difference between a cat and a dog? You might say, well, the cat has pointy ears and the dog has floppy ears, or something like that, right? Or cat's eyes and dog's eyes are a little bit different. And what you start doing is you start identifying features of the thing itself, and you start picking what the thing is based on those features. And the idea behind convolutional neural networks is that they then filter images to extract features from those images and to learn those features. And when they see sets of features clustered together in an image, it makes it more efficient to identify that image and what that image contains. But where that gets really exciting with CNNs then is that one of the things about it is that a computer may see features in an image far differently than a human does, and in some cases can be better able to identify stuff in the image than a human will. So let me give an example. There's a very famous model that we built for diabetic retinopathy, where the idea was that we had a bunch of doctors label a bunch of images of a retina scan, and a doctor can diagnose like diabetic retinopathy in a retina scan by finding blood clots in the retina and saying this blood clot looks like it's diabetic retinopathy, this one's harmless, and identifying those features. A computer doesn't have those limits, and as a result, it may see things instead of being pre-trained to look for blood clots. It could see things in the images that a human may not see and identify those consistently. And as a result, some of the models that were created in research were as good as, if not better than, specialists. But where it got really exciting then was now it's a case of the data of these retinas also had other attributes of the person who owned that retina, such as their birth assigned gender or their age. And some scientists said, well, what if, here's all the images of people who were born male, and here's all the images of people who were born female. Can a computer spot patterns in those to be able to determine the birth assigned gender or not? No human could do that. And so they ended up doing that, and CNNs, convolutional neural networks, to be able to filter it, got it right 98% of the time. Right. So, again, being able to extract features from an image is what convolutional neural networks are all about. And in this case, computers were able to identify features that humans don't see. And, think about the possibilities that we can do with that for things like, disease detection and whatnot, when looking at images and breaking away from how a human sees features, but still being feature-based. And that's what I love about CNNs, and it's why I'm so enthusiastic in teaching them and in computer vision, because the scenarios that you can open up are amazing. Just like the people who took pictures of the sky, and it was something, maybe the color, maybe different patches in the sky or something like that, that allowed a computer to be able to match a picture of the sky to an air quality index reading, and they were able to build a detector for much cheaper than the typical detector, because it's built in, it's a camera built into your phone that you take a picture and then suddenly, you see the sky. I just yanked the power out of my laptop, sorry. Plug it back in. I'm getting so excited. You get me excited talking about CNN, Seamus.
Yeah, and it's quite fascinating, the advances in the area of computer vision as well, because now a trending use case for computer vision is what we call object localization, where you have a bounding box. So if you look at an image, I'm sure people have seen these, like people walking or cars driving, and you're able to identify each object within an image. I think CNNs are pretty good for that, but there are new models coming out. If you want to talk a little bit about that, that can help with that bounding box problem.
Yeah, I mean, the underlying Yeah, the underlying technology is very similar. It's instead of it classifying the entire image to say this is a cat or this is a dog,
Right.
or this is a diseased retina or this is a retina of somebody who was born male. The idea behind when object detection is instead of looking at the entire image, there are algorithms that slice the image up and allow you to do a classification of that. And when you slice it into smaller and smaller things and do those classifications, then you can begin to detect in the image where the thing is.
Mm-hmm.
So for example, instead of just saying this is a picture of a cat, that would be a case of there's a cat in the upper left-hand corner, or the cat is sitting on a mat, or those kind of things. And then you can identify multiple things within the image. But the underlying principle is just the same. Instead of just doing a single shot classification of that image, you are getting multiple classifications of multiple zones in the image and then detecting where the things are within it.
Yeah, no, it's fascinating. We're covering a lot of it ODSC now. Text to image is a big area in computer vision, or text image generation these days as well.
Yep.
But let's not go down that rabbit hole, because I want to continue talking about the book. And speaking of text, I do love the fact that you've dedicated about four chapters in your book to deep learning for natural language processing, or NLP. So what is this? What is it about the combination of deep learning and NLP that's makes it such a powerful combination?
Great question. So I think, first of all, from the employability perspective, the two biggest areas that people are hiring for, according to our research in Google, and was in computer vision and in natural language processing. So that's one of the reasons to dedicate a lot of time into NLP.
Oh, interesting.
So one of the things that's very exciting for me about NLP is about how it can empower communication, and it can break down barriers, not just machine translation, but also semantic understanding of text, and then being able to, translate that between people. I just find is, if the better we can talk to each other, the better world that we can build for each other. So as a result, NLP is very powerful there. From a commercial perspective, it's very powerful. A lot of implementations in chatbots are just the tip of the iceberg. Right. I think there's more and more happening in that space. A lot of people are moving into the audio to text, so you can do live transcription and stuff like that. And then live transcription and translation just becomes really powerful. I spend a lot of time teaching it for that reason. And also, there are a lot of fundamentals that one needs to learn because language is complicated. It's much more complex than image. And so when you want to learn how to do language, particularly in computers, you have to understand, first of all, how computers represent the language, how algorithms work that allow you not just to understand the words, but to understand sentiment within words. And then once you start getting the sentiment from within those words, then you can start doing, for example, classifiers around sentiment. Is this text toxic? Is this text safe? Are we talking about sports, or are we talking about technology? That's a really, really complex task in any language. And, so to be able to build around that and to understand the algorithms for how sentiment can be calculated mathematically and accurately is something that's foundational that one needs to do. But we just do it. I'm doing it all in code. Don't worry. No Greek letters and no math. It's all code. Right. But just talk a little bit about that. And then once there's an understanding of that, and how words or subwords can be tokenized, and then sentiment around them can be learned. And then things such as, sentiment within texts can be learned, or text can be generated. And those kind of things are the type of thing that, I find really exciting. And I find, like I mentioned, is going to be huge from an employability perspective. So it's good to get the foundations of that. And it also makes for some really cool demos.
Excellent. Yeah, and I think we've been using NLP in the industry quite a long time now. I think myself, I started using it maybe back something like 12 or 13 years ago, but it's come such a long way since from bag of words and basic TF-IDF models. And by the way, to this day, we still use them, so they still work. Yeah. But what are some of your favorite new NLP deep learning models, or deep learning models applied to NLP?
Yeah, so I mean, I think I'll talk about two. I think one that I cover a lot in the book is called LSTMs, long short-term memory. And the idea behind LSTM, which is very useful from a NLP perspective, is that if you think about how words appear in sentences, sometimes the word for you to be able to predict or understand isn't dependent on the previous word. It's maybe dependent on words much earlier in the sentence. So for example, if I said, In Ireland, I studied in high school, so I had to learn how to speak blank. What would you say? Right? You know, it's going to be Irish or Gaelic, right? But you understand that, you know, you as a human understand that because you have the context from the beginning of the sentence where I said in Ireland, right? And so long short-term memory is very, very good for that type of thing, for being able to understand text like that, to be able to map sentiment in text like that, as opposed to, like, you know, where the word Ireland was towards the end of the sentence, and then it would be easier for one to guess. So long short-term memory is really, really powerful for getting us deeper understanding of the text in sentences as a result. You know, if I said, you know, today was sunny and there was a beautiful blue blank, right? You know, blue sky is, you know, usually you would say, although I tested this with one person and he said blue moon, but everybody else said blue sky. And, you know, but the idea there was that because the words blue and sky are beside each other, you don't really need long short-term memory. And that would be the classic type of algorithms. RNNs or earlier algorithms would be good for that. But as you start finding sentiment deeper and further away from your target words, that's when things like long short-term memory are very important. Another one that came out more popularly after I published the book, but if I do a revision of the book, I'll add it, is called Transformers. And the idea behind Transformers is really for meshing. I like it for like meshing two sentences together. Like if you're doing a translation, you know, you're not going to translate word for word, but you have a transformation between the first sentence and the last one. Some languages put the verb at the end of the sentence, some put it at the beginning of the sentence. And if you were doing a straight literal translation, that's really difficult, but transformers are powerful for that. And then transformers become really powerful for text generation. Stuff that I've been doing recently, people who follow me probably have seen the Stargate AI project, where we kind of fed a bunch of AI models. So we built a bunch of AI models and fed them with the scripts from the TV show Stargate, and we had it generate new scripts. And then we brought the original actors in to do a table read of these new scripts, like 25 years after they filmed the show, and had like a reunion with scripts that were written by AI. We had a lot of laughs, and it was really fascinating. And that was created using the Transformers that I just mentioned.
Yeah, I believe I spent a lot of time browsing your model garden on GitHub, and I think you've got models in there for BERT, various transformer models that just need some fine tuning. So that's pretty powerful. And if I recall correctly, I think one of the chapters in your book, I think chapter 7 or 8, did go into RNNs, recurrent neural networks, quite in depth, and give that examples of what you were talking about, LCMs as well. So that's, I think you did a pretty good job there in covering all that. So definitely, if you have a chance, check out Laurence's book on RNN. So moving away from the book for a little bit, because I know you're Google Brain, you're on the TensorFlow team. Some of the other things that Google has been working on, which I've always found quite fascinating, and in particular, before I was a Python developer, I spent a lot of time in Java, and by association JavaScript. And sometimes, like, even though it's one of the most popular languages in the world, as you said, sometimes JavaScript doesn't get the respect that it deserves. And I think a lot of people in the community was like, okay, we understand why they went to Python, but why JavaScript? Why not Rust or I don't know, some other language? God forbid R. I think that's R. I was a pirate way before I was a Python programmer.
I think, I mean, going back to the numbers that I mentioned earlier on, that if you really want critical mass of people with the skills and building these kind of things, you have to go where the developers are. And the top two languages, I believe 58% of developers use Python, and 52% of developers use Python, and 48% use JavaScript. So it's a clear low-hanging fruit there, that to be able to empower JavaScript developers gives you a way to reach a huge population of developers to be able to build machine learning and use machine learning algorithms. So that's the first part. The second part, of course, is the fact that when you build something for the browser, there's no install, there's no dependencies, the browser is the platform. And to make it easier, to make it as easy as possible for people to be able to use machine learning, it just makes all the sense in the world for it to execute within the browser. And how would you do it within the browser? Once upon a time, in the good old days or the bad old days, however you see it, you'd have to ship some kind of plugin, right? And then that plugin would execute stuff. I built part of my career at Microsoft shipping a plugin called Silverlight, which was an amazing plugin, but it was still a plugin. And you end up hitting friction there in the browser anytime you have to install anything. And so to me, it made all the sense in the world, and to the rest of us, it made all the sense in the world that if there was a way that you could ship machine learning models to the browser and have inference executing on them within the browser, and to be able to accelerate that with, because now the browsers can access GPUs through like WebGL, and so to be able to do all of those kind of things, it just made all the sense in the world to have a JavaScript-oriented version of the libraries, so that you could define and train models in the browser should you want, but more importantly, you could run inference on pre-existing models in the browser to be able to do, whatever scenarios are suitable for the browser.
Yeah, I remember those days, Microsoft Silverlight, yeah. We used to joke.
That's my fault, sorry.
I did a lot of implementations. No, the framework was great, but it was always the context of the environment. And we used to joke, this is a very poor implementation of a rich web experience. But
I'm sorry about that.
No. That was the evolution of all this, and that's what I do love about the JavaScript library you guys have, TensorFlow JS, because it's a great sandbox. I was just in the I don't know where I found the model. It was in GitHub Model Garden, or it was the TensorFlow Hub, but it was a 2D image to 3D. So taking a 2D image, like a pre-built model, just installing the plugin into my browser, uploaded a few images, and there they were.
Yeah.
Almost lifelike. So again, and again, great job to you and your team, because I think not only do you provide some fantastic educational resources, regardless of what level a person's at, but some of these are just fun to play around with. You know what I mean? And making learning fun like that is with interesting use cases is fantastic. Yep. And so I mentioned at the top of the interview, we've got a webinar titled Making MLOps Cool Again. And MLOps, I think we started doing it 3 years ago at ODSC conferences, calling it Data Ops, AI Ops, DevOps meets data. Now the industry has settled on MLOps, and we've gotten a flood of content around MLOps. So everyone's either pivoting MLOps or doing MLOps, but TFX came out, I think it was 3 years ago. So you guys were pretty early on the whole machine learning workflow on the cloud. Right. I was pretty excited about it. So tell us about where TFX sits in this whole ecosystem.
Sure. We always like to describe the ecosystem and the skill sets that somebody needs to be able to deliver machine learning successfully is like there's 4 phases or 4 columns. Right. The first one is really data acquisition and cleansing. Where you're going to get your data, where your data scientists can do amazing work doing stuff to pick the best and most optimal data sets and all of that kind of stuff. But then once you have that data, to be able to get that in a way that makes it easy for a model to be trained, and all of the tools for like sorting, it's all the S's: sorting, splitting, slicing, and sharding the data. And then the second part is training the model itself, which is where most of the attention tends to be paid, and most of what we've been talking about today has been training the model, but that's just one of the 4. The third one is then deploying that model and being able to do what it needs to optimize your model for whatever the deployment surface is. If you're deploying it into a gigantic cloud infrastructure, a big model that works fast might be better. If you're deploying it to a mobile phone, a small model that might be a little bit slower is, of course, better. And so managing all of that deployment. And then the fourth part, of course, is managing, understanding how it works, getting feedback from it, all of that monitoring and maintenance of it, so that you can feed back and continue the process. And when you put all of these 4 together, that's really MLOps. And so TFX was designed, it stands for TensorFlow Extended. And so it was designed to be able to break you out of just the model training part, or just the data part, or just the optimizing for whatever your deployment part is, and do the types of things that somebody wants to do when they go through that entire life cycle. And the whole idea is we want to kind of put a stake in the ground to say that, we want to have a methodology to do this that's free and open source, that anybody can use, that it's not a commercial service. And again, along the whole theme of being able to seed the community with the tools that will help them be successful. And then that rising water floats all boats, right? So it was very important to us from a very early stage to be able to give that MLOps and to do the big thinking about how people build, deploy, and manage, optimize and manage something, and to give as much open source there as possible.
Yeah, exactly. There's lots of different standards and ideas around pipelines and data pipelines, model pipelines.
Yep.
TFX has done quite a good job in that, so do go check out how they implement various pipelines for machine learning workflows on that. And again, I would, looking at your personal website, which is quite entertaining, Laurence. I see, again, we mentioned you're a prolific author. I couldn't even count how many books you've written at this stage, but it's quite impressive. But I'm going to ask you, does AI influence any of the fictional books you write? Because to be honest, I haven't read any of them yet. But
Shame on you, Seamus.
It's going on my reading list. I need a recommendation.
Yeah.
First recommendation is, which one should I read first?
Oh boy.
Has AI influenced any of those?
So I'll answer the second. I'll answer the second part first, and actually not yet. I haven't had AI influence any of them yet. But I want to do something in that space in the future. But one of the things that when I talk with sci-fi authors and TV producers that I know, I always push that back to them, is that AI in media tends to be very cliched. It's either big bad killer robot or it's Pinocchio. But the reality of AI is neither of those. And it's, there's a massive greenfield for somebody to write interesting fiction around what AI really is. And I'm not a good enough author yet to do that myself. One of these days, hopefully I'll do it. But there was a brilliant movie made a few years ago with Joaquin Phoenix. I think it was called Her. It's either Her or She. I always get it wrong. Where he had like an AI assistant in his ear, and then she evolved. And watch it; it's brilliant. And so when it comes,
sure.
Yeah. So when it comes to like stories about AI that are realistic, I think that's the best that I've ever seen. And one of these days I would like to do something, but that's a very high bar to be able to reach, and I don't think I have the talent to do it. But I'll take a shot.
Excellent. And how about some reading recommendations? I'm just checking that out. It's called, I think it's called Her.
Her. Okay. Yeah. Reading recommendations from mine. One of the series of books I wrote was called the Legend of the Locust trilogy. And it was kind of like, it was a young adult series that was very much like Harry Potter meets the X-Files. And the primary protagonist is a young Irish lad. So I think you might like that one the most.
I'll definitely check that out. And who are your inspirations? Like, what do you read? Since you're I'm not even sure you have time to read yourself.
Well, the one that I'm reading at the moment that I'm fascinated with is there's a Chinese author called Qixing Liu. And he has written a very famous trilogy called the Three-Body Problem trilogy. And first of all, it's brilliant. It's based on hard science, not just like space opera like Star Wars, which of course is fun. Right. But his stuff based on hard science is very, very challenging and very, very good. It will totally change how you look at the universe. And so he's my current favorite author that I'm actually devouring the Third Body trilogy again, because I flew to Europe a few days ago. I had a 10-hour flight, and I think read 3/4 of that book on that flight. And definitely, if you haven't read him, he's one to look out for, because his work is just breathtakingly good. I could never be half as smart as he is.
In addition to yours, I'm adding that to my reading list as we speak.
Oh, cool.
And, so let me see here. There was one question from the audience, and one additional one I want to bring up, which is quite interesting, from Mohammed. Very, very thought-provoking question, I thought. So he's saying, I've been studying artificial intelligence and machine learning for some time, and my goal is to use AI to eradicate poverty in developing societies. But I realize that the structure of society is based on the production of more wealth. Do you agree with my conclusion? Question: can artificial intelligence and machine learning help people in poverty? I think that's. I definitely have an opinion on that.
Sure. I mean, I'd love to hear your opinion too. But I think there definitely is an element that a structure of just almost every technology or science is driven by being able to generate wealth. But it doesn't mean that generating wealth is the only thing that it's good for. So I think that's the first part. Secondly, generating wealth isn't always necessarily a bad thing. How do you lift somebody out of poverty is by helping them generate wealth. And, so I think, technology like this one can be used in those ways. I always like to share one story. It's not an AI story, but it was a great example of technology being applied to help lift people out of poverty. And it came from a friend of mine in Africa. I think he was in Nigeria. He was either Nigeria or Ghana. And he told me of a really innovative solution that happened where it was farmers who want to get their produce to markets. It's very expensive for them to transport their produce from their farm to the markets. So there's often a middleman who will do that for them. But the middleman, they can only afford to take it to one market. But market A may not have the best prices today. Market C might have the best prices today. And if market A has bad prices today, by the time the middleman has taken it to the market for them and the price are low, the farmer can actually make a loss on their produce, and driving them even further into poverty. So one company created really innovative solution, low tech, high innovation, where it was they sent somebody around every market first thing in the morning. They took the prices of all produce and then they send that out over SMS. So now a particular farmer, will receive that SMS. They pay a low monthly fee for the data, and they receive the SMS and they realize that if I go to market C today, then I'm going to get the best price for my produce and I don't have to rely on a middleman, and I will take it there myself, and they will maximize their profits on the produce. Again, that was technology where the company making it were obviously making some money off of this one, but they were cutting out middlemen and they were bringing the ability for this farmer to, not be pushed deeper into poverty, but to lift themselves out of poverty. And like any technology, I think there are innovative uses like that. So Mohammed, I really, really appreciate you asking. But I do agree, first of all, I agree that your conclusion is possible, but I do believe that with innovative use and with people using it with a good heart, that they can actually help lift others out of poverty. And it's up to us all as a whole to make that as easy as possible. And that's what I'm doing in my job, is to raise that floor so that anybody can learn this stuff. All of the stuff is available for free. The educational material is available for free. And whatever else we can do to help people understand this stuff and do better with it is, let me know and I'll see what I can do.
Yeah, I think that's very well said, and rings true to what you've been doing right across your career, Laurence. So, sincere thanks for all that. Yeah, for myself, I think that's a really interesting topic. Mohammed, I agree with your first point there, Laurence, that absolutely AI, like tech, and if you extrapolate that in all industry, it's pretty much a profit-driven motivation, and there's good and there's bad with that. But I think AI, because it's I know it's a weird thing to say, it's post-tech. Like tech has been around since whatever, tech revolution, the 70s and 80s, and we saw the good side, like, my favorite Clint Eastwood movie, The Good, the Bad, and the Ugly. So I think the AI industry as a whole was early to understanding the opportunities, but also the problems that AI can bring. So, I attend a lot of other academic conferences mostly to figure out what's going on. And, I remember Jeff Hilton, Andrew Ning giving they were doing a workshop, which at a technical conference is like a whole day, a series of talks on AI for good, and then subsequent years AI for climate. And that was even back in 2016. So if you're just in your own kind of bubble, just online, learning AI, you can feel like, well, what's the point of all this stuff? But if you start to look at some of those academic conferences and what they're doing, and the AI for good, and ODSC, we've been running a data science for good, and then we got a little cooler and we call it AI for good. Then we call it responsible AI. So there's a whole movement within the AI industry. So look up, AI for good, responsible AI, where people are. So lots of people don't focus on this problem. Lots of companies don't focus on it, but there's a lot of people, that has to be said, who are making great efforts within the industry to make sure AI is responsible. It's doing good, AI for good. So check that out. Loads of organizations on that, number one. Number two, there are nonprofits actually doing this. So I'm sure you've heard of Kaggle. Lots of people are fans of Kaggle. There are some AI for good competitions on Kaggle, but there are other organizations out there. One of our favorite is Data Driven, and they're all about AI for good projects, lifting people out of poverty. So if you go to Data Driven's website right now, you'll see lots of projects you can actually get involved in yourself. So that's the second one. The third one I'm kind of sad about, because I think the pandemic has really kind of hurt us a bit. So when we started ODSC, we started as a meetup first here in Boston. It was the Boston Data Festival. Now we have about 50 or 60 meetups running around the world. And one of the large focus we had was on hackathons. Back in 2015, we did a hackathon with the New York Housing Department. But you find in New York, these landlords, they had centrally controlled heating or cooling. So in the winter, they would switch off the heating. In the summer, they would switch off the cooling because they're trying to get rid of tenants who are paying low rent because of rent control. They want to replace them. And they're playing games. And then the tenant would go to housing court and the judge would say, switch back on the heating. And, you know, there would be like tenants would get tired of this. So this startup started installing heat sensors within the apartments. And then they had a time series of how their apartments were being heated or not cooled. And then they could bring, the advocates could bring that information to the judges. That was one. Back in 2017, we did a hackathon around human trafficking. So we invited a bunch of groups from different companies to come in over 2 days. We worked with law enforcement, advocacy groups to come up with a bunch of different apps to help on this. One was a computer vision app where we scanned some of these notorious websites like Backpages and Craigslist looking for missing people to turn an image match. Because remember back then, computer vision wasn't that kind of thing. So Mohammed, don't be disillusioned. There's tons of good examples there. This is a question of do you want to do it? So you're not the first to think about this problem. There's a whole support group. And I also tell people if you're in education, you're probably, like everyone else, like getting your first job in AI is hard. So go to these volunteer groups, go to these AI for Good and nonprofits, offer your services. You don't have to be a fully trained data scientist. You can do some data wrangling. You can be, you know, working with CSV files, data files, SQL. There's a lot you can do there. So I think there's a ton you can do in this. So, you know, step one is read Laurence's book, check out all his education, learn how to do this stuff, and then go find yourself a place you can volunteer, do a hackathon. But there's a ton of stuff you can do here. And, you know, there's lots of stuff that can go bad with AI. That's why you have a whole machine learning safety, machine learning ethics at ODSE conferences. But there's a lot of good you can do as well. And it's a great way to learn. It's a great way to stuff like that. So sorry, that's such a long answer to kind of a long question, but
yeah. Well, what I'm really encouraged by is the fact that we're having these conversations now, first and foremost. You know, previous technology revolutions like the advent of the smartphone, the advent of the web, and all of those kind of things, we weren't having those conversations. And the people who made the largest profit out of these kind of things were Western Europe and North America, where other countries got left behind. Well, relatively speaking, you know, the largest profits, the largest companies came out of those areas, maybe also China to some extent. But then, you know, with the whole idea of the AI revolution, first of all, we're having those conversations now. And then secondly, you don't need to be close to a Stanford or an Oxford or an MIT to be able to get the skills or the skilled people to be able to solve these kind of problems. You can be like the example that I mentioned with the really innovative solution I'm sorry, I forgot which African country, like Nigeria or Ghana, or one of them, that, you know, to be able to do those kind of things. And the goal is nowadays that more and more often the tools are free, the technology is free or very, very cheap. So for example, even things like we have Google Colab, which will allow you to create machine learning models in the browser using back-end GPU resources that are free. You can even use a very, very expensive laptop or something like that, or desktop, to be able to create these things because the compute power is in the cloud and freely available to you. And so these are the kind of things that we're doing to try to help it be that the centers of excellence and the centers of power, and frankly, the centers of profit, don't necessarily need to be Silicon Valley or London or, you know, Shanghai. So it's, you know, and I think, you know, that is one of the really important things that's happening right now. And hopefully then, I love that Mohammed has asked this question and brought this up, because we feel that's very important, that, you know, for everybody to benefit, then everybody has to benefit. You know, if only a few benefit, then nobody benefits. And so it's like that. This is a lot of the work that we're doing, and any ideas, any feedback that you have, I'd always love to hear.
Excellent, Lauren. And just to wrap this up, you're going to be speaking at ODSC Europe and
Yep.
5 or 6 short days. Can you just give us a quick rundown of that session, and then we can...
Yeah, so I'm going to be talking about natural language processing and going through all of the foundations for natural language processing for somebody to be able to build something, for understanding text, recognizing sentiment in text, and even generating text. So I'm going to just do very hands-on to understand things like there's tokenization, there's vectorization. Vectorization is that you kind of give words a pointer in a higher dimensional space to understand their sentiment. Like if it's pointing that way, it's good. If it's pointing that way, it's bad. You know, those kind of things. It's a lot of fun. And so to be able to train models around that, like I said, to detect sarcasm in text, or to detect, you know, positive and negative sentiment in text. And then we'll also do a little bit of text generation where I have a data set based on traditional Irish songs, where you'll be able to build something that will generate traditional Irish song for you, which is pretty appropriate as I'm here in Temple Bar. Maybe I'll bring some of the lyrics for them down to me and see if I can get somebody to sing some.
That's excellent. Maybe I'll bring my mom along. She might finally attend one of my conferences if I don't Irish music there.
There you
Well,
go.
Laurence,
Perfect.
Laurence, listen, thank you so much for coming on the show. Thank you, second of all, on behalf of everyone, for being such a great educator and doing so much to help educate the community in AI. And absolutely very excited to meet you in person next week and listening to your session.
Sounds good. I'll see you there. Thank you. And thanks everybody for tuning in.
Thank you, everybody. Yeah, join us in a couple more weeks for our next live stream interview. And otherwise, have a fantastic week and weekend. Bye now.
Thanks. Bye.